In this video, we're going to discuss how to determine where the graph of a rational function will have a vertical asymptote or a hole. So when we're talking about a rational function, rational has that word ratio in it, so it looks like a fraction. And specifically, when we call it a rational function, the numerator and denominator are polynomials. So we're not going to see any square roots or cube roots or anything like that. The numerator and denominator will be polynomials. So we'll see positive powers of x, some coefficients, maybe multiple terms, but no radicals or anything like that. So the domain is going to be all real numbers, almost, because since p and q are polynomials, they themselves have a domain of all real numbers. And the only thing we have to worry about then is the fact that we're dividing them. So we just can't have a denominator of 0. So all real numbers are going to be in the domain of our rational function unless they make the denominator 0. And then those values that we exclude from the domain will either give a vertical asymptote or a hole in the graph, because we have to skip over those x values. So for example, let's say that the value 2 is not in the domain. We can't have a point with an x value of 2 on our graph. So if we're going along graphing the function, well, what happens when we get to 2? We can't draw a point there. So one possibility is that there's a vertical asymptote. The other possibility is that maybe we're going along drawing the graph and then we just kind of skip over that x value and then we keep going. So that would be what a hole in the graph would look like. So we're going to talk about how to determine which is the case for those excluded values. Alright, so here we have a rational function, and first let's find the domain. So in this case the denominator is a quadratic, so we'll want to factor that, and we can factor an x from each term. And so we can see that we don't want x to be 0, and we also don't want 2x minus 1 to be 0, which means that x can't be 1/2. So the domain here is all reals except 0 and 1/2. Those are the only two values that have to be excluded. So in interval notation, we would say we can include everything less than 0, everything between 0 and 1/2, and everything greater than 1/2. And this starts giving us an idea of what the graph's going to look like. We're going to have something happening at 0 and something happening at 1/2, where we skip over those x values with either a vertical asymptote or a hole. So to figure out which x values are holes and which ones are asymptotes, we also need to factor the numerator here, and we need to look at whether or not the factor appears in both places. So for example, this factor x, which led us to exclude 0 from the domain, appears in both the numerator and the denominator. If that's the case, then that gives a hole in the graph. So we have a hole at x equals 0. Now this factor is what led us to exclude 1/2 from the domain, and that factor is not in the numerator. We don't have a 2x minus 1 factor in the numerator. So that tells us that x equals 1/2 is a vertical asymptote. Here's another example. So again, we have a quadratic in our denominator, so we'll need to factor that. That factors as x plus 6 times x minus 3. And so we can see that the domain is all reals except -6 and 3, because those are the x values that would make the denominator 0. So in interval notation, we would say the domain includes everything less than -6, everything between -6 and 3, and everything greater than 3. And then when we go to graph this, we'll want to know what's happening at those two x values that we excluded. So we excluded -6 because of the x plus 6 factor, and that factor also appears in the numerator. So that means we have a whole with an x value of -6. And we excluded 3 because of the x minus 3 factor, and we don't have one of those in the numerator. So x equals 3 is a vertical asymptote on the graph of this function.